Hi, this is Nova Area Tutoring, and I wanted to share with you a worksheet that I found through the years that's very helpful with teaching the disc and washer method with AP Calculus AB. In this case here, let R1 be the region in the first quadrant bounded by y equals x, the y-axis, and the line y equal 1. Let R2 be the region in the first quadrant bounded by y equals x squared and y equal x. Let R3 be the region in the first quadrant bounded by y equals x squared, the x-axis, and the line x equal 1. So the first question is we're going to write an integral expression to set up the situation that we have, but we're not going to evaluate. So we're just going to practice the setups of these. Okay, so for the first question here, it says the volume of the solid generated by revolving region R3 about the x-axis. Okay, and just a reminder, when we're doing the wash, I always set things up as a washer, and I'm going to show you why. So in this case here, it would be pi, and it's going to be big R squared minus little r squared, and these are going to represent the radius, not the regions R1, R2, and R3. This is going to be the radius when I create my partition within the region. So in this case here, we're doing R3, and we're going to rotate that around the x-axis. Okay, so since it's a vertical partition perpendicular to the axis of rotation, we know it's going to be with respect to x. So this is going to be a dx. Okay, so we know our big R squared and little r squared have to be with respect to x. So we're going along the x-axis. That means the limits of integration are going to go from 0 to 1. Okay, so now here's why I treat everything as a washer. What I do is I use distance. So when I'm doing it with respect to x, I always call distances top minus bottom. Okay, so in this case here, I consider my big R squared to be the farther distance of the partition to the axis of rotation. So if we look at this here, the farther distance is going to be the top of the partition down to the axis of rotation. So now how do we generate, what point is that on there? Well, that's represented by y equals x squared. So that means when I set up my integral here, my big R squared is going to be x squared, and then the formula says to take big R squared and square it. Now, my little r squared, this is actually a disk and not a washer, but I treat everything as a washer formula because what's the distance between the bottom of the partition and the axis of rotation? And you can see the bottom of the partition is touching the x-axis exactly. So my little r is equal to 0 in this case, which makes it a disk because there will be no hole when we rotate it. So that's how we get our setup. And it seems through the years using this top minus bottom technique, it's been helpful for my students. Okay, so we'll continue on with this in part 2. Again, this is Novi Area Tutoring. Thank you.